Hello, guys. Welcome back. So, today we'll try to apply whatever we have learned so far in the previous classes under the lecture series. And I'll be solving questions from previous year papers of Delhi School of Economics. And I've collated these questions, and for each question, the year and link for the question paper is given in the description box below. So yes, let's start solving the question. So first question you see is a really interesting question. It says that if the correlation between variables x and y is zero, so the moment hear the term correlation, you must understand that ultimately it talks about covariance between x and y, and this being zero, ultimately you have to understand covariance divided by standard deviation of x and y will be there. Okay, and so the options are the regression of y on x and x on y intersect at right angles and pass through the mean value x bar and y bar. The regression of y on x and x on y do not intersect at right angle but do pass through. And third option is they intersect at right angles but do not pass through. And fourth option is they do not intersect and do not pass through. सो एक बात यहाँ पे समझिए कि आपका रिग्रेशन क्या होता है अगर आपने लिखा है y इज बीटा वन प्लस बीटा टू एक्स प्लस सी वाई, तो यहाँ पे आपका बीटा टू जो होता है बीटा टू इज समेशन एक्स आई वाई आई अपॉन समेशन एक्स आई स्क्वायर. And this summation xi term is also the numerator of covariance xy. So this being 0 means your beta 2 is 0. So in that case, your regression becomes a constant line y is equal to beta 1. And similarly, in the reverse case, if you run a regression of x on y, so by the same analogy, you can understand that x will also be equal to some constant, say c1. So how will this look like if I plot y and x? So y is equal to beta 1, so let me say this, x is equal to c1, so let me say this. So it is obvious that they'll intersect at right angles. So one thing we are clear. Also, the second part is that they pass through the mean value x bar and y bar. So now what is mean value of x bar and y bar? You must understand that beta 1 is y, or you can summation yi divided by n. So beta 1 को आप लिख सकते हैं y bar minus of beta 2 x bar. Now this beta 2 is equal to 0, so beta 1 in this case becomes y bar. And similarly, on the same analogy, when you run the regression of x on y, so in that case, intercept term will always be equal to x bar. So the correct option in this case should be the regressions of y on x and x on y intersect at right angles and pass through x bar and y bar. Okay, so let us move to the next question. So next question says that given the linear regression y is equal to alpha plus beta x, a very high correlation between variables x and y necessarily, so this is a very important word here, necessarily implies that the slope coefficient beta is statistically significant. This does not make sense because this is not entirely this will not be necessarily implied by this correlation between x and y. The observations xy lie along a straight line. This can be our potential answer. Small changes in x causes large change in y. Again, this is not necessarily true. The regression line is steep. The slope of regression line depends on this value beta, and this beta depends on the value summation xi yi and summation xi square. So we are just given that this is very high, we do not know anything about this, so this is also not necessarily true. So in this case, your correct answer should be the observations xy lie along a straight line. Because unnecessarily high correlation, we don't know whether it's a high positive correlation or high negative correlation, but we know that there is a sufficiently high degree of linear relationship between y and x. So the observations xy lie along a straight line will be the true answer. Okay, so let us go to the third question. Third question asks us, it says that Consider the following model estimated using OLS, where the OLS model is this: yi is equal to beta xi plus ei, where ei's are the residuals, I goes from 1 to n, and where there is no intercept. Now, this is very, very important. There is no intercept term. And variance of EI is sigma square, that is, it satisfies the assumption of homoscedasticity. Which of the following statement is not true? Not true, it asks. So it says the first option says that the R square from this regression can be large even if X and Y have low correlation. So you must understand that R square is ESS upon TSS, and this ESS is expressed in deviation form, and this deviation form presupposes an intercept term. So this statement is true that the R square from this regression can be large even if X and Y have low correlation. The least squares residuals need not sum to zero. Again, this is if you follow the assumptions part, summation xi ei or is equal to zero, और इसको हम matrix notation में x transpose E is equal to zero लिखते हैं. So x transpose, the first column of x transpose is nothing but the column containing 1, right? And this is for the intercept term. So this necessarily makes the sum of ei to go to zero. So this need not be true. Least square residuals need not sum to zero. Okay. Third option is the mean square error is given by summation yi minus y bar ka whole y hat whole square divided by n minus 1. That is nothing but this is your total variation yi minus y hat ka square divided by n minus 1. So this again is true, mean square error. So we are left with only the fourth option, and it says, just a minute. So it gives the least squares estimator of the slope coefficient is given by this term. So now you must understand this is the least square estimator expressed in raw forms, and this also supposes an intercept term present over there. So in this question, the statement which is not true is the least square estimator of the slope coefficient is given by this value. Okay, let us move forward and try to solve questions. So we come to question number 4. It says that an analyst trying to estimate the demand for rice has estimated this model where D is these are the descriptions about the variables used. So D is the demand for rice per household, Y is income, P is price, N is household size, and these are the standard errors associated with this 0.1 and P is 0.05 and of N is 3. Second model is a bit different where demand per household and price, really sorry for this, demand per household and income variable has been divided by the household size, and that's how they estimate or they come to this model. Now it says that which of the following statement is true? So we are not giving any other thing except the R square values from both these models. So, if you remember in one of our earlier discussion where we were talking about R square, one of the limitation of R square that we had talked about, that the model cannot be compared if the models they differ in their number of explanatory variables. So in this case, it is quite clear. So it said model 2 is preferred to model 1. So this option will not be right. Model 1 is preferred to model 2. Again, not right. The two models are not comparable in terms of fit and none of the above. So in this case, the answer should be the two models are not comparable in terms of fit. Okay. Next question. Next question. It says that consider the regressions yi star is equal to this is let's say, yeah, so this is hat and these are the term. So consider the regressions yi star which is equal to beta 1 hat star plus beta 2 hat star xi star plus ui, and yi again sorry this is yi is equal to beta 1 hat plus beta 2 hat xi plus ui hat. where yi star is equal to a constant times yi and xi star is equal to a constant time xi, where w1 and w2 are constant. So if you are, fairly versed with how to calculate these beta 1 and beta 2, so, beta 2 hat star if I want to find out. So beta 2 hat star kya hoga? Summation xi star, I'm just writing in deviation from yi star divided by summation xi star ka whole square. Now, this will also get multiplied by W2, this will get multiplied by W1. So, outside the summation term, you'll have W2 times W1, summation xi yi, and here you'll have W2 ka whole square, summation xi square. So, now this term is your nothing but beta 2 hat. So, यहाँ से क्या होगा? One of the term of W2 will get cancelled. So, beta 2 hat star is your W1 divided by W2 times beta 1 hat. So you can see, so beta 1 hat star is written as W2 times beta 1 hat, and which is not true here. So this option is not right. This option is also not right. Let's come to this option. And let's discuss this option first because this is more obvious, and obviously it's an MCQ, so you must be very smart also to answer these questions. So it says that r square xy is not equal to r square x star y star. You must understand that, in our lecture number 2, we discussed that correlation coefficient is devoid of units of measurement. And so, it does not matter whether you express, xi and yi in whatever units, your r square of that, that is correlation coefficient between x and y will not change. So this option automatically is wrong. So in this case, correct option is variance of beta 2 star hat is equal to this term. And I encourage you to find this out yourself.